We're on to the distal convoluted tubule. So after that nephron loop, and what happens here? We're going to have more reabsorption of sodium, more because we've had that a lot already, right? Following sodium is going to be chloride and water. But this is the most important. We're going to have secretion of potassium, and that's actually going to be exchanged for that sodium. Those are going to work together in antiport. Also some hydrogen, which we've seen with antiport with sodium before. Secretion of drugs and toxins primarily happens here. And lastly, reabsorption of calcium. Now we are getting into where these processes are regulated. Remember that the filtrate entering the DCT is about 100 milliosmoles. The urine that comes out of the collecting duct can be anywhere from 100 to 1200. That's going to be partially influenced by this distal collecting duct. So we're going to start to see regulation of this and this together. That's going to be aldosterone. And then we're also going to have regulation of this via parathyroid hormone. So let's look at this process in our cells. Here is a familiar picture with our epithelial cell, our lumen, our ISF, and our capillary. And I already have some processes labeled here in terms of reabsorption and secretion. So what things do we want to secrete again? Let's start with toxins and drugs. Passive diffusion across this basolateral surface. And then this is going to be either a carrier or pump to get this, to secrete these out into the lumen. So we want to get rid of those. Then we've got a protein that we've seen before. It's an antiporter. So these are both exchange pumps, which are pumps. So they're going to use ATP, and they're both antiport. Aldosterone regulated, I'm going to put with an A. So first I'm going to do my one without an A. We want to reabsorb sodium, and we're going to secrete hydrogen ions. Regulate that pH. So same thing here. We've got sodium being exchanged for hydrogen. Great. And we saw this same mechanism before, these ATP pumps that exchange sodium and hydrogen ions. Then we've got these aldosterone regulated pumps, meaning they are put into the membrane via stimulation from aldosterone. I'll show you this in the next video. But we're still going to want to be reabsorbing sodium, secreting potassium. Aldosterone regulated pumps are exchanging potassium and sodium. So potassium's going out, secreted, sodium is being reabsorbed. These pumps are put into the membrane via stimulation by aldosterone, a steroid hormone produced in the adrenal gland. The last thing for the distal convoluted tubule is calcium reabsorption. So we want to reabsorb calcium. That means this way. Parathyroid hormone is stimulated by low calcium, remember? So it's going to insert calcium channels. Calcium channel, calcium channel allows calcium to be reabsorbed. Pretty cool. That's going to allow us to maintain calcium when levels start to get low. I said that was all, but the other things that I told you were chloride and water are both going to follow the reabsorption of sodium. So if we have reabsorption of sodium, we can have water follow. And we actually have chloride pretty much goes paracellular. Is going to follow the positively charged sodium ion. So sodium is what's regulated, sodium potassium via that aldosterone pump. Water and chloride can follow the movement of sodium. And that's how sodium reabsorption causes water reabsorption as well.